Now we're going to look at some inequalities rather than equations. So with inequalities, we don't have an equal sign. Instead, we're using these symbols: greater than, less than or equal, greater than or equal. Now, I don't know if you're familiar with interval notation. This is in the preliminary chapter of the book, section P.1, if you need to review it. Interval notation, we'd read this as interval from 2 to infinity. It's another way of saying x is greater than 2. So it'd be the numbers 2 or larger on a number line. And another type of notation I want to be sure you're familiar with. When drawing number lines, rather than using the circle notation to indicate greater than, we're going to use a curved parenthesis here for numbers greater than 2. And then again, this would be the interval starting at the number 2 and going off to infinity. So 2 to infinity. The curved bracket indicates we want x strictly greater than 2 and up to, but not including infinity, because you can never actually equal infinity. Alternatively, if you're trying to express x greater than or equal to 2, we want to include the 2 in the interval. So rather than using the solid dot notation, we're going to use a square bracket here to indicate we're including 2 and going on off to the right to infinity. And with interval notation, we'd write that as the interval 2 to infinity, including the 2 but not including infinity. This interval here, this means x is greater than or equal to 3 but less than 6. So we're including all the numbers from 3 to 6. We're including the 3, but we're going up to but not including the 6. You can also write it this way: 3 is less than or equal to x is less than 6. Okay, so actually solving linear inequalities, this is section 1.4 in our book. It's very similar to solving equations. There's just one thing you have to watch out for. So when solving equations, we can add and subtract a number to both sides. We can multiply and divide a positive number to both sides. And we can multiply and divide a negative number on both sides of an inequality. We just have to watch out. We need to reverse the inequality if we do that. So I'm going to play around with some numbers here a little bit just to try to illustrate that. So I think we can all agree that 6 is less than 8. So if we take 6 less than 8 and we add a number to both sides, we get something that's still true. And if we subtract a number from both sides of the inequality, we get something that's still true. If we multiply both sides by a positive number, we still have a true statement. If we divide both sides by a positive number, we still have a true statement. But if we look over here, get that out of the way, take 6 less than 8, divide both sides by -2, we get -3 and -4. Now if you think about it a minute, -3 is bigger than -4. Think about temperatures. -3 is warmer than -4 when you're talking about degrees Fahrenheit or degrees Celsius. And if we multiply both sides by -2, we get -12 and -16. Again, -12 is larger than -16. So to keep things true, we have to reverse the inequality, point the arrow in the opposite direction if we either multiply or divide both sides by a negative number. So it's kind of something to keep in the back of your mind. With negatives, the bigger numbers are actually smaller numbers. -100 is much smaller than -1. Okay, so looking at a couple examples here. 3 subtract 5 is less than 7. Add 5 to both sides. Divide both sides by +3. Since we're dividing by a positive number, we don't have to reverse the inequality, giving us x is less than 4. Written on a number line, we'd use a curved bracket on the 4 because we want to go up to but not include the 4. And we want the number smaller than 4, so going off here to the left to -infinity. So that gives us the interval from -infinity to 4. With interval notation, you always want to read it left to right. So the smallest number first, comma, and then the larger number, the right-hand end of the interval. The second example here, we've got -2x plus 8 greater than or equal to 14, so we can subtract the 8, but then we need to divide by -2. So since we're dividing by a negative number, when we do this step of the solution process, we need to reverse the inequality. We're going to go from greater than or equal to less than or equal. And so our solution, x is less than or equal to -3. So we use a square bracket on the -3 because we're including the -3. And we're going off to the left to -infinity. So we have the interval from -infinity to -3, including the -3. Okay, compound inequalities when you have more than one restriction on the variable. So in these two examples, just want to compare the and statement versus an or statement. So if we have 2x plus 3 is less than 7, and we also want x plus 1 to be greater than 2. So if we solve each of these two inequalities, we get x is less than 2 and x is greater than 1. So we need both of these to be true. We want numbers that are smaller than 2, but also bigger than 1, which leaves us with this interval here. X is less than 2, x is greater than 1. We need the overlap between the two restrictions. So we want the interval from 1 to 2 for our final solution. Where if we have an or statement, we want either condition to be true, and as long as one of the conditions is true, it's good. So solving the left-hand inequality here, we get x is less than 4. Solving the right-hand inequality, we get x is greater than 11. So either the numbers less than 4 are good, or all the numbers greater than 11 are good. So we can call that the interval from negative infinity to 4, union with the set from 11 to infinity. If instead of using the union symbol, you'd rather just write the word or, I'm fine with that. A little more intuitive if you don't want to get into all the set notation. Okay, let's take a look at another problem here. Notice for this and statement, we have 3x plus 4 is less than or equal to 14, and 0 is less than 3x plus 4. So we had the same expression here, 3x plus 4. We can combine the two statements because it's an and statement. We want 3x plus 4 to be less than or equal to 14 and also greater than 0. So when you're looking at one of these compound inequalities, I like to think of it as being a three-sided inequality. And to solve this, we're going to try to get x by itself in the middle. And when we do the operations, what we do to the middle expression, we have to also do to the left-hand side of the inequality and the right-hand side of the inequality. So I think of these as like three-sided inequalities rather than a two-sided equation. We've got three sides. So looking at that specific example, 0 is less than 3x plus 4 is less than or equal to 14. In order to isolate the x, we need to subtract the 4. So we'll do that in the middle, but we also need to subtract 4 from the left side and subtract 4 from the right side. So this is what I mean by three-sided. You have to do the same thing to all three pieces of the compound inequality. So that'll give us negative 4 is less than 3x is less than or equal to 10. Divide everything by positive 3. We don't have to mess with the arrows. And we're left with negative 4/3 is less than x is less than or equal to 10/3. Writing that as an interval notation, we use the curved parenthesis for the negative 4/3, a square bracket for the 10/3, and are going smallest to largest here in the order. Okay, the next example over here, negative 2 is less than 5, subtract x is less than 7. We need to subtract the 5, and we do that to all three sides, giving us negative 7 is less than negative x is less than 2. And then to get the x by itself, we need to divide by the negative 1, and that means we're going to have to reverse the inequalities here. So that leaves us with 7 is greater than x is greater than negative 2. It might help to do this on a number line just to see what's happening. We've got negative 2, we've got 7. We want the arrows pointing away from the 7 towards the x, so x is smaller than 7, but x is larger than negative 2, so it's the numbers in between, from negative 2 to 7. So that gives us the interval from negative 2 to 7 for a final solution. And again, notice we're writing this smallest to largest left to right.